Okay, so we'll be talking about quantum mechanics. Okay, in quantum mechanics, we will talk about quantum information. Okay, and since quantum information, we'll also talk about quantum computers. In fact, as well, computers. Okay, like how quantum computing works. So, for quantum computers or information, it is said that, let's suppose, if we have an apple, okay, that's the worst apple I have made till now. Let me make it better. Can I make it better? That's the best I can make. Apple. Okay, we have an apple and we smash it. Okay, we smash it. We smash it in such a way that it shreds to small pieces. Okay, so according to quantum information, if we have the fundamental information, if we have its information of particles, if we had, it's the opposite I made. I am a weird guy, sorry. If we had information of particles, we could create something known as a quantum hologram. Okay, quantum hologram is same object made. Okay, so let's suppose if we know that apple, okay, apple has certain particles, and we have the information of particle, information or detail. Okay, so this can be used to create apple hologram. Okay, and how I could relate is, since the information here, the key point is information is not destroyed, so the object can be remade. Okay, that's the condition for the quantum information. That's what quantum information says. So one more thing, quantum information is yeah, so that's quantum information. And now, since we already have quantum information, let's talk about quantum computers as well. So quantum computers, we have talked about quantum computers before. Quantum computers. Okay, so let's talk about the, first of all, I will tell you that it works at lower temperature. Okay, at very low temperature, near absolute zero, near absolute zero. Okay, and because the processors, if I think you guys might have seen image the image. Okay, in the image of a quantum particle, they say it's this long, right? Like it's covered in gold coated in, it's covered by like a lid which is gold coated. Okay, but actually the real quantum computer is nothing but this small chip. Okay, that's the real quantum computer, the main the main quantum computer. Okay, this is the main quantum computer. I think it's mostly of 128 bits, I think. Yeah, qubits of google google Okay, so then, and whatever's here helps QC function. Okay, sorry, function. Okay, then what else we have here is that something known as, now that we're talking about information on of a quantum computer, how can have information quantum computer works. Let's suppose when information is processed, it's in a it's in a superposition state. So we say it's in state of 1 by 2 1 1 plus 0 0 and 1 over uh, 3 over 2 squared. This is example. If it doesn't add up to 1, just ignore it. 0 1 plus 1 0. Okay, this is, I think, psi, and this is this. Okay, this is just examples. Okay, or I'll just not write this. Okay, so what I'm saying here is that when the information is being processed and there's no quantum coherence, it's in a mixed state. It's this state, this state, this state, and this state. But when the state is broken, it's observed, what happens, that state breaks and we get either one. Okay, one, like 1 by 2 square root of 1 by 2 1 0 plus 1 1. Okay, yeah, so it will break into this. Then, and it has if we talk about its probability density, the probability density is 1 by 2, which is 1/2. Its probability density is half. Okay, so then now that we have talked about quantum, the probability, and we are also, there's something known as there's something known as coherence. In coherence, there's something. What is coherence? Coherence is nothing but information. The coherence is the state not being affected, our best point, our best is not being affected. What we want to do is that we want the state not to be affected in such a way that, because if affected or affected, whatever you say, what will happen is stay the answer can be wrong. Okay. And when it's like observed, when it's observed. Okay, let me write properly over here. It is observed. Okay, observed. Okay, so this is what happens when observed, and we get a wrong answer, error. Okay, so that's what we have to prevent. And then when it is observed and the state breaks, that is something known as decoherence. Okay, decoherence. Okay, and this is what it is. Okay, when, so what coherence and decoherence, this is something known as it's also related to quantum cryptography information. This is can be used as in QKD, quantum key distribution. Okay, I have talked about, so I will not talk in detail. So quantum key distribution, what happens in this is that if this is a person over here and he is messaging, and this is a person who receives the message, through quantum key distribution, many qubits are sent. So what is happening here? A superposition state. Okay, superposition state. Okay, I think there's a gate applied. It's a Hadamard gate. Okay, to put it in superposition state. So when receiver, let me send it as receiver error. When receiver receives, and receiver gets information, what happens is this is a quantum channel, quantum communication, a signal, quantum signal. Okay, so what we do is that, so what happens is after he got this information through normal channel signal, normal signal, all right, the basic, in which form it is written, the basis is asked from sender that from sender. So then what happens then when it's received from the sender, that in which basis it is it in like plus, negative, positive, or like up, horizontal or vertical? It's plus, negative state, positive state, or horizontal state, or vertical state. Either of these he will just ask. They are divided into two. This is one, and this is the second one. Okay, they are two different. So the sender receiver asks only for these, either one of them, and then he will just remove unwanted data, unwanted data. Okay, so then if, let's suppose there's an interceptor, so then when data compared, something goes wrong. Okay, something goes wrong. Okay, that shows that there was a third person. It will tell us about the third person, and we will know that there was an interceptor, and so we can be secured. Okay, yeah, that's it.